Statement of Cauchy's mean value theorem. If two real-valued functions fx and gx are continuous in the closed interval ab, derivable in the open interval ab, then there exists at least one real value c in the open interval ab such that f prime c divided by g prime c equals to fb minus fa divided by gb minus ga, where gb not equals to ga. Let us try to understand Cauchy's MBT in the diagram. X-axis, y-axis. Let us take a function y equals to fx. This is the point x equals to a, and this much is fa, and this is the point x equals to b, and this much is fb. The function is continuous in the closed interval ab. The function is derivable in the open interval ab. Then there exists a point c. This much is fc, such that f dash c equals to fb minus fa divided by b minus a. This is the statement of the Lagrange's theorem. And if we draw a tangent at this point, then the slope of this tangent is f dash c. Now, if we draw another function, say this one, this is y equals to gx, and this is the point x equals to a, and this is the point x equals to b. So this much is GA and this much is GB. The function gx is continuous in the closed interval AB and derivable in the open interval AB. Then there exists a value c in between AB such that g dash c equals to GB minus GA divided by b minus a. Now here, if we draw a tangent, then the slope of this tangent is g dash c. In Cauchy's MBT, f prime c by g prime c is fb minus fa divided by gb minus ga. Verify Cauchy's MBT for the following functions on the indicated interval. Fx equals to x square, gx equals to x cube on the interval 1, 2. Here both the functions fx and gx are polynomial, hence they are continuous in the closed interval 1, 2 and they are derivable in the open interval 1, 2. Then there exists a real value c such that f prime c divided by g prime c equals to f2 minus f1 divided by g2 minus g1. So from here we have to find c. Let us try to understand the question in the diagram. Here is the function y equals to x square, and this is the point A where x equals to 1, and this is the point B where x equals to 2. So for the function fx equals to x square, f1 is 1 and f2 is 4. F prime x equals to 2x, f prime c equals to 2c. Here is the function gx equals to x cube. g1 is 1 and g2 is 8. G prime x is 3x square. G prime c equals to 3c square. So 2c by 3c square equals to 4 minus 1 divided by 8 minus 1. 2 by 3c equals to 3 by 7. So c equals to 14 by 9. Another question. Verify Cauchy's MBT for the following functions on the indicated intervals. Fx equals to e to the power x, gx equals to e to the power minus x on the interval 0, 1. Here both the functions fx and gx are continuous in the closed interval 0, 1 and derivable in the open interval 0, 1. If we see in the diagram, this is the function e to the power x and this is the function gx equals to e to the power minus x. Here we see this is the point 0 and this is the point 1. So at 1 the functional value is 2.72. Fx equals to e power x, f0 equals to e power 0, that is 1, f1 equals to e power 1, that is e, f prime x equals to e power x, f prime c equals to e power c. Gx equals to e power minus x, g0 equals to e power minus 0, that is 1, g1 equals to e power minus 1, that is 1 by e, g prime x equals to minus e power minus x, g prime c equals to minus e power minus c, which is minus 1 by e power c. Now according to Cauchy's MBT, f prime c divided by g prime c equals to f1 minus f0 divided by g1 minus g0. So f1 is e minus f0 is 1 divided by g1 is 1 by e minus g0 is 1 and f prime c is e power c and divided by g prime c is minus 1 by e power c. So e power 2c equals to e minus 1 divided by e minus 1 into e. So we have e power 2c equals to e. So 2c equals to 1. C equals to half. Verify Cauchy's MBT for the following functions on the indicated interval. Fx equals to sin x, gx equals to cos x on the interval minus pi by 2, 0. Work out this problem yourself. If you have any question or doubt, drop it in the comment box.